Over it in a couple of minutes. All you need to do is go home, pop on my YouTube channel, watch today's lesson. The second part of the lesson will be the quiz, and we will go over that in detail. Okay, so today's do it. We'll get started with that. I also have homework answers to show you guys. Make sure you're getting the homework right. So let's see if we can cram all of that in 20 minutes and get going here. All right, so 3x minus 1 equals negative 16. This is a routine, run-of-the-mill, two-step equation. I like to call them, it's where you send in the ground troops. It's as easy as it gets. Add 1 to both sides. 3x is negative 15. If you didn't get negative 15, that's a mistake from earlier in the year. We need to get that straightened out in the relearn packet. Divide by 3, x is negative 5. Okay, any question on the first one?
No.
All right, so let's go to the second now. All I do on the second question is switch which side the x is on, but we still do it the same way. We always attack plus or minus first, so it's minus 7. What's 3 negatives and 7 more negatives?
Negative 10.
Nice. Negative 10 is 2x. Divide by 2. X is?
Negative 5.
Negative 5. Sweet.
Yeah.
Okay, now, learning to recognize situations. Danger, 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 as my good buddy Steve Irwin would say. What kind of 3 is this?
Positive.
Positive. What kind of 2x is that?
Negative.
Does that negative sign have anything to do with the 3?
No. Does not.
That's the big misunderstanding kids have. So I'm going to go minus 3. Don't forget that's a negative 2x. So many kids lose the negative when they bring it down. Don't go doing that. Negative 2x is 10 divided by negative 2. That's equals it. Die. X is negative 5. Remember, when I divide by a negative, I have to change the original sign. So I get negative 5. Any questions so far? All right, so these are, I would have considered to be very basic from last year. The third one gets a little tricky with the negative there, but the first two is certainly very easy. Now I'm going to distribute the 4, because I see the number outside the parentheses. So I get 12n minus 20 equals negative 42. So I need to add 20 to both sides. And I get 12n, die, is equal to negative 22 divided by 12. And sometimes you just get weird looking answers. I can reduce this a little bit more and say negative 11 over 6, and I'm done. Now that brings me to a really interesting point, and we talked about this year. Why are you so hung up on converting to a decimal? Is it because when you were a little kid, teachers always said express your answer as a decimal?
Yeah.
Elementary school? Mm-hmm. There's a reason for that. Do you want to know why? Because your elementary school teachers can't do math. Every once in a while you get one who can. The vast majority of them hate fractions. They can't do it. I mean, they can do it, but they have no idea why. They have no idea what's going on. They teach elementary school because they like kids. They teach elementary school, oftentimes, because they don't love a subject like math or like physics or history or something like that. It's more to them about the kids. So now you're being taught by people whose ability with fractions is limited. So generally speaking, isn't it easier to interpret a decimal than a fraction? So they say, oh, let's just convert them to decimals. Then they feel more comfortable. And because your elementary school teachers feel more comfortable with decimals, they drill decimals into your heads. But the world doesn't operate on decimals. The math world operates on fractions. So you got to get used to fractions. Negative 11 over 6, that's the end of that. Any questions? Now, with that in mind, go ahead.
Does that mean like on a test, if you were going to write like 36 over 4, does that mean you have to put...
Well, I would express you to simplify a fraction and make that 9.
But not if it has a decimal?
Right, and
a long decimal.
you don't want to make it into a decimal, okay? Unless you see express your answer as a decimal. Other than that, if it's a fraction, leave it as a fraction. I promise you, I get fractions. I understand fractions all the way through. Now, let's use that to come up and take a look at number 2, because number 2 on the quiz was the most missed question. So, there were a couple of ways in which people went wrong. And I just want to show you that the reason nobody got 100 is nobody knew how to express their answer. And it was actually easy. You went past the answer for so many of you. Negative 2, 3 is here. And 3, 7 is here. So I draw that, and I think the class knew to make the right angles. We've gone over it enough in the homework to know. And when you go over the length of this side, I'm going from negative 2 to 3, that's a length of 5. And when I go over this side, I'm going from 3 to 7. That's a length of 4. So the next thing we do, this is a right triangle. So what do we use? Yeah, come on. Right triangles. What do we use in right triangles? Pythagorean theorem. Good. And I like to express it as leg squared plus leg squared equals hypotenuse squared. But you can do a squared plus b squared if you're more equals c squared. If you're more comfortable, what does c always have to equal? The hypotenuse. Don't forget that, or you could get tricked on it. Now, this becomes 5 squared plus 4 squared, because here's my right angle, the 4 and the 5 are the legs, the hypotenuse is across from the right angle, equals, I'm going to call it h squared. 25 plus 16 is h squared. I add them up because they're on the same side, I do the same operation. 41 is h squared, and now people kept going in the wrong directions. They felt, so many of you felt compelled to convert to a decimal. Just square root both sides. Done. Square root 41. That's it. Do not convert to 4 point whatever. I'm 6 point whatever.
6.4.
6.4, yeah. Don't convert to that. Just leave it. Square root 41. We are completely done. Now, if it came out and said square root of 49, would you leave it square root of 49? No, because what is the square root of 49? 7. No decimal necessary. The truth is that the square root of 41 does not equal 6.4. It's close, but it's not equal to it. In fact, you can't write a decimal that equals the square root of 41. It's impossible. It's what you call an irrational number. It cannot be done. Okay, number 1 looked pretty good. I'm not going to bother going over numbers 3 and 4 because they look extremely good, okay? Y equals 2x squared plus 5x over the interval from -1 to 3. So I'm going to plug into 3 first. So y will equal 2 times 3 squared plus 5 times 3. This is 9 times 2 is 18. 5 times 3 is 15. Add them up, I get 33. That gives me the point 3 comma 33. Yeah, oh yeah, we did well on this question. Much better than we've been doing. We weren't perfect, but we have definitely improved. And I know I'm going pretty quick, but y equals 2 times -1 squared plus 5 times -1. -1 squared is 1, times 2 is 2. 5 times -1 is -5. That's -3. So if my input was -1, I get -3. I love seeing the coordinates written on your paper somewhere. That really tells me where you're going with this and that you have a clue. Remember, any coordinate is always input, output. Now I'm going to do change in y over change in x. So 33 minus -3, that come out to -3? Yeah. 33 minus -3, where am I here? 33 minus -3 over 3 minus -1. 33 minus -3 is 36. 3 minus -1 is 4, and 36 over 4 is 9. Okay? So again, Wyatt, if it reduces to a whole number, I do expect that.
Okay.
But if it's not a whole number, let it be. Particularly with something like rate of change, which is, you know, never a decimal because it's a slope. All right, do we have any questions on the first 2 questions from the quiz? Wilfredo?
I thought you said that when you get a negative, you have to square it, then negate it.
If what I said here was this, if I get a negative and I want to square it, I have to put it in parentheses. If I had a negative in front, then I would negate it. But without the negative in front, I'm not going to negate it. Okay? And when I say in front, I mean in front of the x term, not just in front of the 1, because now it's in parentheses. So the whole negative is being squared. Okay. Now, let's go to today's homework. We'll go over that for about 2 minutes or so.
Last night's homework?
Yeah, last night, the one due today. Wilfredo, number 1's a pretty straightforward question. If we take a look at number 2, I think you get a good example of what you were just talking about. See how this says negative x squared here? That means square the x, then negate it. So look what I did. The -5 is in parentheses. I squared it to get 25. Then I negated it. That's how I got the -25. As opposed to, look at the first one, there's no negative in front, so I just squared the -5 and came up with +25. Does that make sense to you now? Okay, good. All right, any questions on number 2? All right, here's number 3 with, a linear graph is a straight line. 2 ways to do exponential. I have it here and here, okay? This is just a fraction raised to a fractional, like a half to the x power. This is a whole number. Quadratic can be in 2 ways. The big thing is that if it looks like this, it's something that could be modeling flight, all right? An upside down parabola, if you will. Here's my graph of the parabola. Remember, the zeros are where it crosses the x-axis. The axis of symmetry in this case, it looks like x equals 2. Is that what it is? Right? We went over it today at Extra Help. A lot of people on their relearn packet, some people did it, some people didn't. You must write x equals on an axis of symmetry. You can't just write the number, in this case 2. It has to be x equals 2. And here again is the question we just went over. Notice one length is 4, one length is 3. So leg squared plus leg squared is hypotenuse squared, 16, 9. I get the square root of 25 there. Notice I did take it down to the 5 because the square root of 25 is 5. Okay? Michelle, is that making sense to you? Okay, good. I just saw you give it the eyeball there a minute ago. All right. Here's an average rate of change question. We knew we were going to have a hard time on that on the last test. I'm hoping on the next test that we ace this question. All right. As the work I have seen, you are getting better at this. You're getting much, much better at this. Okay? Any questions about that? All right. And last but not least, the graphs, they'll cross somewhere between 4 and 5 minutes. Okay? That's how I would set my graph up. And there is distributing and there is equations. Any question on distributing or equations? Distributing and equations are big stuff from the other day. That's very important. We're good? All right, don't go copying answers. That's not what I'm looking for here. I'm looking for you to compare your work with what's going on here and to see if there's anything that you recognize that you didn't see right away. We're good? Okay. So let's get back to today's lesson. And, what are we going to learn today in class? It's always in the same place. What are we going to learn? It's on the board if you want to look. Yeah, how to identify examples of associative commutative properties and find the missing value. So today is all about properties, and I think if you understand the English language and you have a decent command of vocabulary, you're in pretty good shape. Here's a picture that represents 3 plus 4. How can I tell the 3 here? Lily?
She didn't.
Yeah, good. So does it make a difference if I shade the first 3 in or the last 3? Nah, 3 plus 4 is the same exact thing as 4 plus 3. In other words, I can switch them. So if I want to look at the commutative property, the definition of the word commute is to switch. Everybody write switch in your blank there. And I think that you have intimate familiarity with the word commute. In fact, they say that religion cannot be taught in schools, but I actually think that schools somewhat, maybe in the privacy of the home, teach religion when it comes to commuting. I really do. What do you guys do in the wintertime when you hear we might have snow coming? Anybody pray for snow?
Yeah.
Anybody do we got some hands coming up. Oh yeah, we pray for snow. I personally don't. I hate snow. I like snow on weekends, but I want to save the days off for the spring when the weather's beautiful and I can go do my fly fishing and photography. But the snow is coming and all the kids are like, oh dear God, please, snow, 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 snow. Oh, I want a snow day, please, please, please. And then they watch the news. It's like the only time kids watch the news. And they watch the news for the weather report. So they're watching the weather report, and inevitably, the well-dressed weatherman or woman steps up and she goes like, for tomorrow's morning commute. Remember those words? Okay. What is a commute? A commute is when people start in Patchogue, and they hop in a car or a train, and they go where? No, they go to New York City. And then what do they do in the afternoons? They switch it. They go from New York back to where? Patchogue. So you go Patchogue to New York to Patchogue. That's commuting. Commuting is switching. I'll get to you in a second. What? 5 to 4, then what? 4 to 5. Albany to Bermuda. Bermuda to Albany. We're switching here. 8 times 5, 5 times 8, 3 plus 7, 7 times 3. Now, the first one and the fourth one would be called the commutative property of addition. Why do you think we call it addition, guys? No rocket science here. Okay, Andre? Because they're adding. And this one would be called what for B and C? Everybody?
Associative property of multiplication.
Commutative property of multiplication. Okay, Wyatt, go ahead.
You're wrong. We don't watch the weather report. We watch to see if our school is closed.
Yeah.
Yes, that's usually part of the weather report, though.
Or we use the internet.
We wait to listen to the voicemail.
Yeah.
Oh, yes, the voicemail that comes in the mornings. Yeah, I am showing my age a little bit here. Years ago, they didn't have that communication system. Okay, is subtraction commutative?
No.
Can you switch the order with subtraction?
You cannot do that.
Well, let's try it. Let's put a minus here. What's 5 minus 4? What's 4 minus 5?
Negative.
Apparently, it's not commutative. Okay. Next up, associative property. Now, I absolutely positively know the definition of associative. And I have a funny feeling some of you might know it from the same situation too. Anybody in here ever once or twice in their youth get in trouble with their parents? Ever happen to anybody in here? Sarah's sitting there like, what are you talking about? It never happens. Parker, never. You never got in trouble, right? Not in your whole life, right, Batman? Now,
Me.
my son Bobby, I had 2 sons. Jimmy almost never got in trouble. Bobby, oh my God. Now he's really straightened out. He's doing fantastic. But back in the day, he used to have this friend named Raymond Rivera. Every time I turned around, he was getting in trouble with Raymond Rivera. So one day, he gets suspended in like 3rd grade. He and Raymond Rivera trashed the bathroom. They took all the paper towels out, threw them all over the place, tried to clog the toilets, threw toilet paper all over the room and everything else. And I just remember being so mad. I remember picking him up over my head, pushing him up against the ceiling. And I remember screaming, did Raymond Rivera feed you when you were born? Did Raymond Rivera clothe you? And I go through all the things we ever did. I must have held him up there for like 3 minutes. And he's like, look at me like, I'm gonna die, I'm gonna die. And I go, why do you listen to Raymond Rivera? I put him down. Now, truth be known, I have no idea if Raymond Rivera got him in trouble or if it went the other way around and he got Raymond Rivera in trouble. I don't have a clue, and I didn't care. All I said to him was the following words, which you may have heard once or twice in your life. You will not associate with that person again as long as you live. Ever hear those words before? Ever have your parents say that?
No.
Mine, you've had them say that to you? Yeah, that means you got in trouble with somebody and they weren't letting you near that kid anymore. Well, that was what happened with my son. To associate with someone means to be grouped with them. Okay? Papers. So, to associate with someone means to be grouped with. Now, look here. Who is the 5 grouped with here? The 4. Who's the 5 grouped with here? The 8. If I change the person or number that the term is being grouped with, I am changing who it is associated with. Parentheses, by the way, are called grouping symbols. Okay, that's why it's being grouped with. Look over here. The 5 is being grouped with whom? 2. Here with the 3. So this is, and these are both examples of the associative property. This is the associative property of addition. This is the associative property of multiplication. Now we look over here. Is the following an example of associative or commutative? Andre?
Associative.
Wrong. Commutative.
I meant to say.
Because look, the 5 and the 2 are together. What's true over here?
5.
The 5 and the 2 are together. Have to do. Yeah, if this was the 5 with the 2, what would it have to be over here? Somebody has to go with the 7, right? Because you have to change who it's being associated with. All right, so when it order. All right, you're ready to go on tonight's homework there. We got through everything. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Zane. Adios, amigos y amigas. Why do I think Jake got a lesson once or twice about not associating with certain people? How can I see thunder rolling from Dad as he says that to him?
What time is it in the library here?
5:30 to 7:30 tomorrow. Tuesday nights, 5:30 to 7:30. Okay?